try some negative number. X is -1. -1 cubed is -1. This is -4 times -1 is 4. -1 with 4 is 3. Try x is -2, and I think it's going to be 0. X is -3, it's going to be -15. Okay, so after plotting some points, at least we have some idea of how the graph roughly is going to look like. Of course, more point you plug in, and the final the graph you're going to have, and I claim the graph you guys are going to have is like this. 0, 0 is right here. X is 1, -3, right here. 1, -1, 3 is going to be right here. So okay, the graph looks like this. And you see what, of course, I make the graph on purpose. You see what? It has a symmetry about the origin, okay? You have a point, you flip over the origin, you have another point. But it doesn't have any symmetry about the y-axis because, say a point right here. I flip over the y-axis, I don't have the point on the graph. Not symmetrical about the y-axis. Similarly, I have a point right here, I flip over the x-axis. It's not a point on the on the graph anymore, so it's not symmetrical about the x-axis. But if I have any point on the graph, I flip over the origin, I still have a point on the graph, you see. Any point on the graph, flip over the origin. Okay. So you can test for all of those using the algebra that I showed you. Test for symmetry about the y-axis. Right? Do what? Change about the y-axis. Right here, you change x to -x. So the original one is y equal to x cubed minus 4x. For the new equation, whenever I see an x, I'll change to -x. So y is equal to -x cubed minus 4 times -x. You see? This example, I got 2x. So I see I got to change all the x into -x. And let's simplify. Y cubed negatives still stay negative. And then -4 times -x is plus 4x. And look, the original equation and the new equation are not the same. Okay, it's different. So what? It's not symmetrical about the y-axis. Okay? To test for symmetry about the x-axis, what do I need to change? The x-axis is right here. I test for symmetry about the x-axis, I have to change y to -y. Y change to -y. And see what I got. Original one, y equal to x cubed minus 4x. New equation, -y equal to x cubed minus 4x. See, y change to -y. And simplify this. Multiply or divide both sides by -1. I got y equal to -x cubed plus 4x. The new one and the original one are not the same again. Not symmetrical about the x-axis. Okay, now what about the origin? The origin. What do I need to change? I have to change x to -x and y to -y. Okay. So my original equation is y equal to x cubed minus 4x. I have to change both, right? Y becomes -y equal to x cubed. That becomes -x cubed minus 4 times -x. See? All the x becomes -x. All the y becomes -y. Try to simplify. -y equal to -x cubed plus 4x. You guys see it? -y stay there, same. -x cubed, so it's odd exponent, so the negative stay the same. -4 times -4x. Now simplify this one more step. Divide or multiply both sides by -1. See what you got. Y is equal to x cubed minus 4x. The original one and the new one. Actually the same, right? Y equal to x cubed minus 4x. It's the same. And according to what we just learned, if you change both x to -x and y to -y, the equation doesn't change. It means what? The new point is still on the graph, right? Same graph. And you can say that for sure the graph will be symmetrical about the origin. Keep in mind the algebra steps are a lot more important than the graph, because later on I will have many problems, many equations you don't see the graph, you don't have the graph. But without the graph, it's okay. You'll still be able to test for symmetry. And I'm talking about with your future courses, say me count one. Okay, we're gonna come back to this in a more professional way. We start from here. And let me show you another example, last example for this section. And you guys can see that the graph may have more than one symmetry. And it's not a function, by the way. We learn function later on. Okay, it's just any graph. I'll show you this. Example number 4. X squared plus y squared equal to 9. Guess what? This is a circle, right? Whenever you see an equation like x squared plus y squared equal to some number constant, it's going to be a circle. This is a graph, a circle of radius 3. This is the origin right here, 3 right here, 3 right here, negative 3 right here, and negative 3 right there. Okay? X-axis and the y-axis. We have 2 x-intercept and 2 y-intercept. We're going to go over that quick. To find the x-intercept, you let y equal 0. Okay? So you got what? X squared equal to 9. And usually people just take square root on both sides, right? Then x equal to square root of 9. We're missing something in here? Not just square root of 9. Could be plus or minus square root of 9. Now you got two values. X equal to 3 or x equal to negative 3. 2 points. And similarly, you want to find the y-intercept. You let x equal 0, and then same way you solve for y. You got 2 more y-intercepts. Okay. Now let's talk about symmetry. You guys see any kind of symmetry in here? This graph actually has all kind of symmetry that we learned. Y-intercept, any point. You flip over the y-axis, still a point on the graph. And same thing here, flip over the point over the x-axis, still a point, right? And origin, yeah, you flip over the origin, you still have a point on the graph. This point right here, flip over here, this is what? xy becomes negative x, y, the point right here, flip over the x-axis, becomes x comma negative y. You flip over the origin, you got what? Negative x comma negative y. And all those points when we flip over still on the circle. Therefore, this circle has symmetry about the x-axis, symmetry about the y-axis, and symmetry about the origin. And you want to test for it. Right? You change just x to negative x. You got what? Negative x squared plus y squared equal to 9. Simplify, go back to the equation, right? You change y to negative y. You got what? X squared plus negative y squared equal to 9. And simplify this to y squared. And you change both. But right here, you got x to negative x and y to negative y. You got negative x squared plus negative y squared equal to 9, which is still x squared plus y squared equal to 9. So it works. This is symmetry about the x to negative x, symmetry about the y-axis, y to negative y, symmetry about the x-axis, both symmetry about the origin. Got them all. So this graph satisfies all the conditions, all kinds of symmetries. So to wrap up with this section, what we learned in here, we learn about plotting the graph, right? We have an equation in general. We can plot some points to have the graph, and then we learn about the intercepts, right? 2 types, x-intercept and y-intercept. And then we learn about symmetry, 3 types. Symmetry about the x-axis, symmetry about the y-axis, and then symmetry about the origin. Okay? And hopefully via a couple of examples that I showed you on the board with the calculations help you to take care of all other problems pretty much the same way, just different numbers. Okay, and this is the end of 2.2. Let me move on to the next section. I'll be talking about section 2.3. It's also another big section. I think we're going to talk about linear equation. Okay? Oh, a fancy word is linear equation. Easier word is line. Linear equation is line. Okay? So, let's get to the point. X-axis right here, y-axis right here. You have a line. Okay? So today we're going to learn everything about the line. The very first thing that we learn about the line is the slope. Slope is a numerical value. It's a number, okay? It's a numerical value. Slope you see denoted by letter M. And that number could be positive, could be negative, could be equal to 0, and that tells you how steep the line is going to be. So if the slope positive, number M is positive, then the line is going up. M is negative, the line is going down. M equals to 0, then you have a horizontal line. And if the line is straight upward, then M is undefined or infinity. Let me write down here slope M. Positive, the line is going up. M is equal to 0, the line is horizontal. M is negative, the line is going down. And later on when you learn functions, see what function increasing, constant, function is decreasing, and M is undefined. Then you have a line straight up, vertical line. Okay, that's about the slope. Next question. How can we do to find the slope, to calculate the slope of the line? What do we need to find the slope? And I claim that you want to find the slope of the line, you're going to need 2 points on the line. So in general, let me call this point right here x1, y1. The second point right here, x2, y2. And the formula to find the slope of the line is what? Y2 minus y1 over x2 minus x1. Okay? And make it easy for you guys to remember. You see people write it this way. Change of x, change of y over change of x. Okay? Or I heard many people say what? Rise over run. Rise means going up and down, right? Change of y. And run is going left and right, change of x. Okay? So the ratio of change of y over change of x is going to give you the number M, which is called the slope of the line. Okay? Later on, when you guys get to calculus, people denote this way. It's called delta. Delta y over delta x, and this is a short way of writing what? This is change of y over change of x. Okay? Delta. So delta y over delta x. Okay. Now slope of the line. You have 2 points, and change of y over change of x is going to give you the slope of the line. Now, let's talk about some forms of the line. There are many ways to represent an equation of the line. We talked about slope already. Number 2, equations of lines. The very first equation is the very popular one, and the one that you usually use to write your answer down is called the slope-intercept equation. Intercept equation. Okay? And it's written this way. Y equal to mx plus b. Let me box that. Okay. Remember the m? M here is the slope. And you know what b is? B is the y-intercept. So y-intercept, so 0, comma b. I say b is the y-intercept. Okay. Example. Y equal to negative 3x plus 1. This is the slope and the intercept equation of the line. And by looking at this, you can tell right away that slope m is equal to negative 3. Slope is a negative number. What do you know? The line, you know the line is going to be going down, right? And what about the y-intercept? 0, comma 1 is the y-intercept. Okay. Now let's move on to another type of equation. Number 2, we have something called the point-slope equation. Point-slope equation. Okay. And point-slope equation is going to be written this way. Y minus y1 is equal to m times x minus x1. Okay, box that for me. Or some people can write this way. Y is equal to m times x minus x1 and then plus y1 on this side. So all we do to change from here to here is what? We add y1 on both sides. We have the second equation. And I claim that those are equivalent. You can write either way. And again in here, m is the slope. And x1, y1 is a point on the line. On the line. You see what? Actually, this is a more general version of the previous equation of the line. In here, you have a slope and a very specific point, the y-intercept, the point on the line. This is what? A slope, okay? And then any point on the line would work. So let me explain to you in terms of graph, okay? For this one right here. So if you know the y-intercept and you know the slope, see, y-intercept, so it's right here. And then you know slope is right overrun, then slope, you have a line. This one right here, you have any point on the graph, and then you know slope, and you should have a line. And then, of course, you can find y-intercept later. No need to be a y-intercept. Any point on the line. And the slope will help you to find the equation of the line. And I claim that this is, in my opinion, the most important equation about the line that you guys are going to use the most. So, not just college algebra, guys. You get to pre-calculus, you get to calc 1, calc 2, calc 3, or math. Whenever we talk about the line, think of 2D, okay, two-dimensional space. You need to look for two things for me. You look for the slope of the line, and you look for the point of the line. Okay, if you're lucky, you have the y-intercept. That's awesome. If not, just any point on the line. Usually we are right here. Okay. Whenever you have a slope, you have a point. You plug into either one of those formulas, you have the equation of the line. Okay? And I'm going to give you an example, of course, later on when we finish with all the materials, and I'll get to the example. Okay. And then the third type of the line, third type equation of the line is called the general equation. Number 3. General equation. Okay, it's written like this: ax plus by equal to c. I don't know why our books capitalize ABC, but you can write lowercase a, lowercase b, lowercase c. Doesn't matter. Okay. And box that. In here, ABC is a number. Nothing special. Okay. So with this equation, they call general because it can represent any line, and you don't really see anything out of it yet. Okay. And it's general because it's more powerful than the previous two equations that you see right here. Remember when we talk about slope, we have what? Positive slope, negative slope equal to 0. But for the first two cases right here, you need to have a slope to find the equation of the line. This one right here. You don't even see the slope in here, right? So that's why it's called general. Any equation of the line. So, you can have an example like 3x minus 2y equal to 5. So here what? A is 3, B is negative 2, and C is 5. Equation of the line. And question, if you are given like this, can you bring it back to the slope-intercept equation? The answer is yes, right? All you have to do is solve for y. Subtract the 3x on both sides. Let me try to write down here. You got what? Negative 2y equal to negative 3x plus 5. And then divide both sides by 2. You got y is equal to 3 over 2x minus 5 over 2. I divided both sides by negative 2. Okay? And now what? From general form, you just convert it back to the slope-intercept form, and you get all the information about the line right here. Slope is 3 over 2. So rise 3, run 2. Positive number, graph go up. Y-intercept is at what? Negative 5 over 2. Okay, so the intersection is going to be below the x-axis. Okay? So those are the three equations of the line that we learned in this section right here. The slope-intercept equation, the point-slope equation, and the general equation. Okay? Next, let me talk about some special equation for the line. Actually, it's just among those three, but it's kind of special. We have two types of special equation. Number 4. special equations. First of all, the horizontal line. Okay. Line like this, got a horizontal line. X-axis, y-axis. Okay. And the equation for horizontal line is y equal to a constant, say constant c. C stands for constant. Okay, so c is right here. See any point on that line, always have y equal to c, and x is gonna change. Okay, and really this is of this form, mx plus b, where slope m equals 0. You can write this way: y equal to 0x plus c. You see, slope is 0, and y-intercept is at c right here. Okay, and you can even think of this as a general equation: 0x, this is my 0, okay, plus 1y equal to c. So a is 0, b is 1, and c is c, any number. This is the general equation. And the first type of special equation is the horizontal line, where y equal to constant, and x could be anything. Similarly, you have another type of special line called the vertical line. Okay, so let me draw it right here. X-axis, y-axis. Now the vertical line is very similar to the horizontal line, but instead of being horizontal, it being vertical. Okay, and the equation for the vertical line is x equal to the constant. I would say c equal to x. You should write x equal to c, the constant, c right here. Okay, and what about the slope of that vertical line? Is undefined. Okay. The slope vertical line is undefined. So you cannot use slope equation, slope intercept, or point slope equation to represent a line. But you can think of it as a general equation. You can think of it this way: 1x plus 0y equal to c. General equation. Okay. In here, what I'm trying to tell you is what? All the vertical line going to have the equation of x equal to a constant. Okay. Could be 2, 3, 4, 5. Could be negative numbers. Stay on the left hand side. C is for horizontal line. C is positive, the line is above the x-axis. C is negative, the line is below the x-axis. Okay. Next, we're going to move on to the third big item for the line. We'll be talking about the relationship between lines. Relationships between two lines. Okay. So if we have two lines, there are a couple, at least 3 cases you can see in here. If two lines intersect each other, it looks like this. If two lines not intersect each other, it's going to be like this. And two lines right on top of each other, I have to use different colors. Okay? All right? So actually, two lines are the same. And later on, when you guys learn about solving the system of linear equation, it's going to be infinite many solutions. For now, it's just one line, really, two lines. It's the same. We don't do it this here. This one right here, two lines have no intercept. We say that two lines are parallel. 2L here and 1L there, right? Parallel. And now in here, this is conditional cases where two lines intersect each other. And we're going to learn a very special case when two lines intersect each other. Of course, when two lines intersect each other, it's going to create an angle, right? And we only learn a special case in here. If the angle that created between the two lines is equal to 90 degrees, then we say this: two lines are perpendicular to each other. Perpendicular. Okay. So the thing that we are learning today about the relationship between two lines is 2 special cases. If the two lines never intersect each other, we say the two lines are parallel. If the two lines intersect each other, and moreover, make a 90-degree angle, make a right angle, then we say the two lines are perpendicular. Okay. And how do we know if the two lines are parallel? The two lines are parallel if they have the same stiffness, right? So same slope. You look at the slope and you can tell. Same slope means what? Let's go. The first line got the slope M1. M, remember, for slope, so M1 means what? Slope of the first line. The second line got slope M2. And if the two slopes are equal to each other, the two lines are parallel. And what about perpendicular? Say this. The two slopes gonna be opposite reciprocal or negative reciprocal. Opposite reciprocal. Okay? Means what? M1 is equal to -1 over M2. Or another way of writing this is this. Or M1 times M2 is equal to -1. Okay? Let me try to explain to you guys a little bit more about opposite reciprocal. Say you had a fraction, say 2 over 3. Reciprocal means what? You interchange the rows of the numerator and denominator. It's going to be 3 over 2. And opposite means you change the sign. Okay? So if I got a number of -1/3, opposite reciprocal of -1/3 is going to be 3. Or 3 over 1. 3. Okay? So if the two slopes are the same, the two lines are parallel, the two slopes are opposite reciprocal, then the two lines are perpendicular. Okay. Now, time for example. There are many exercises in this section. I claim this is a very important section. But let me just try to bring out some example that I believe is most important. Okay. And you guys are going to use this, those examples, not just as a sample, not just for our class, but for pre-calc and then later on for calculus. Whenever people ask you to find or write an equation of the line, this is what you need to do. Okay. First example. Let's call it. What number? Should be number 4, right? Examples. The first example. Equation of a line containing two given points. Two given points. Okay? So if they give you 2 points, and you know that given 2 points, you should be able to draw a line through 2 points, right? You got 2 points. How do you find the equation of the line through 2 points? Say this point is about 1, 2. This point right here is gonna be 3, 3. I just make up 2 numbers. Okay? I gave you 2 points. Can you find the equation of the line? So we gotta go back to what we learned before. In order to find the equation of the line, you need 2 things. You need what? A slope and a point. Okay? And we find the equation of the line. So the point, we have more than this. We have 2 points. Just choose 1 point. I'll choose a point. It's easier. 1, 2, smaller numbers. I choose a point. 1, 2. Slope. I don't have slope yet, but I have 2 points. Can I find the slope from 2 points? Of course, yes, because I have a formula to find slope. If I am given 2 points, rise over run a change of y over change of x. So m was what? y2 minus y1 over x2 minus x1. Keep in mind this is just a lecture, so I'm writing the formula again, but later on when you guys do the work, you don't really have to write the formula again. Just plug in the numbers. So what? y2 minus y1 is gonna be 3 minus 2 over 2 minus 1. 3 minus 1. Let's go to 1/2. So slope is 1/2, and the point is 1, 2. You have slope and a point. Now you're okay to write the equation of a line. Use the point-slope equation, right? Point slope. Say what? Y minus y1